Today we are exploring Advent of Code 2023, Day 13, Point of Incidence. I'm going to show you 50 lines of code which solve it in 80 milliseconds. Let's dive in. We are given the patterns of ash, dot, and rocks, hash mark, and we need to find a perfect reflection across either a horizontal line between two rows or across a vertical line between two columns. In the first pattern, the reflection is across a vertical line between two columns. Arrows on each of the two columns point at the line between the columns. In this pattern, the line of reflection is the vertical line between columns 5 and 6. Because the vertical line is not perfectly in the middle of the pattern, part of the pattern, in this case column 1, has nowhere to reflect onto and can be ignored. Every other column has a reflected column within the pattern and must match exactly. Column 2 matches column 9, column 3 matches 8, 4 matches 7, and 5 matches 6. The second pattern reflects across a horizontal line instead. This pattern reflects across the horizontal line between rows 4 and 5. Row 1 would reflect with a hypothetical row 8, but since that's not in the pattern, row 1 doesn't need to match anything. The remaining rows match. Row 2 matches row 7, row 3 matches row 6, and row 4 matches row 5. To summarize our pattern nodes, add up the number of columns to the left of each vertical line of reflection. To that, also add 100 multiplied by the number of rows above each horizontal line of reflection. First, I read the input line by line until I reach an empty line between patterns, and then I call a summarize function which returns either the position of a vertical line of reflection or 100 times the position of a horizontal line of reflection. To simplify the code, I first try to find a position of vertical reflection. If I do not find any, I try to find a horizontal line of reflection. A reflection can be either at the beginning or the end of the pattern. I try to find the biggest reflection possible. If the first half of the image is equal to the mirrored second half for every row, then it is the solution I was looking for. Otherwise, I try smaller mirror sizes. In a nutshell, the code tries all possible mirror placements. The twist for the second part is that there is exactly one smudge in each pattern. It means we must ignore one mistake when looking for the reflection line. As you can see, the code is almost identical to the code in part 1. I just slightly altered the condition in the findReflection function. Instead of looking for equality, I calculate the difference, the number of differences between two strings, and subtract it from the allowed number of smudges. There is a line of reflection if and only if I ignore exactly one smudge. After simple modification, we can also use the code from part 2 to solve both parts. That's all I have for you today. If you have any questions or comments about this, please put them below. If you like this video and would like to see more like it, please subscribe. Thank you.